Hey again. So now we're on the first problem of page 193. It's the stop sign one. So I'm going to go through the steps of just figuring out what x is. And then from there, I want you to finish the problem on your own. And then the following page, 194, will have a similar problem that I want you to do completely independently. So let's take a look here. First thing I notice is line AC is a straight line, and a straight line has 180 degrees in it, which means these two angles along the straight line are supplementary. So if I add them together, they should equal 180, and from that I can find out x. So looking at angle ADB, which is represented by 3x, and angle BDC, or CDB, either way, is represented by 8x plus 15. I'm putting that in parentheses. It's not going to change when I combine like terms. It's just showing that this is one angle and this is the other angle. We're adding them together. Together, since they're along a straight line, they should equal 180 degrees. Now, this should look familiar from class. We're going to combine like terms. So I've got two x terms. They're both positive. I know that the 3x is positive because there's nothing in front of it. This 8x is positive because we're adding it. There's no negative sign. So we end up with 11x. 15 is the only number term, so there's nothing to combine it with. So it just stays right here. And it all still equals 180. Remember, we're going to work from top to bottom when we solve this. Okay, next we subtract 15 for both sides to isolate the variable term. So this will cancel out. We'll be left with 11x over here. On this side, we'll get 165. All right, and then I'm guessing it's 15. So we'll check though. We can do one. We could use a calculator for this too. Yep, 15. Okay, so x ends up equaling 15 after we divide both sides by 11. And then we can use that knowledge, the knowledge that x equals 15, to go back and figure out some of the other angles in the problem. And I'll let you do that on your own. Remember, it's called substitution, or you're evaluating the expression. You're plugging in x where you find it in the angles. Okay, good luck on pages 193 and 194. All right, hopefully those last two pages went well for you. We are moving on to page 195, I believe. Let me take a look. No, 194. Nope, 190. All right, I'm just going to restart. Welcome back. Hopefully pages 193 and 194 went well for you. We will now be looking at the first problem on page 195. After I do this example, the expectation is that you will complete those two pages, page 195 and 196, before we meet again for page 197. So this problem involves a rectangle, and an important thing to remember about a rectangle is that all four corners create 90-degree angles. And we've learned a lot about what complementary means. Complementary means two angles equal 90 degrees. So the first question asks, how do we know that angle MON, that's this angle here, and angle LOM, this angle here, how do we know that they are complementary? Well, they are kind of jammed in a corner here, and we know that a perfect corner is perpendicular, which makes 90-degree angles. So they are complementary because they are forming a right angle, a 90-degree angle. So that's useful information, especially if we want to figure out what x is. And indeed, in the problem, you will need to figure out what x is. You also might want to keep in mind that angles that form x's are vertical angles. So you can see this 2x angle, LOM, is vertical with angle QOP. They are across from each other in an x. When that happens, the angles are equal to each other. So I could label this angle here also as 2x, and you'll find that might be useful later in the problem. But for now, let's set up our equation to figure out what x is. Well, this angle plus this angle, as we just discussed, has to be equal to 90 degrees. So I'll come over to this part of the board and write my equation. 2x plus 7x plus 9 equals 90 degrees. Not 180 like last time. This time it's 90 because we know the two angles should equal a right angle. Okay, so let's combine like terms. I've got 2x's and 7x's. That makes 9x. I only have one number term, so that just stays. It all should equal 90 degrees. Now we can subtract 9 from both sides to isolate the variable term. This cancels out, leaves us with 9x equals 81. Divide both sides by 9. And that'll give us x equals 9 degrees. So, further in the problem, you'll be asked to use that information. If we know that x is 9 degrees, we can now figure out angle LOM by plugging in 9 for x. We can also find angle M and O by plugging in 9 for x here as well. So, good luck on that problem, and I'll see you on page 197.